All right. Okay, we're going to take up I added some additional problems where we're solving simultaneous equations by the addition method. Let me start my slideshow. Okay, this time we've got decimals. I think I may have worked this one in class yesterday. I don't remember. Or Tuesday. Okay. What I'm going to do is I'm going to clear the decimals here. I've got 1 digit behind, 1 digit behind. So I'm going to multiply this equation by 10. Here I've got 2 digits behind. So I'm going to multiply all 3 of these numbers by 100. When I do that, that gives me 50x plus 3x equal 14. Here, it gives me 20x minus 10x equals 28. Now I can look for a opposite pair. Well, I've got opposite signs, but I don't have opposite pair. So I would need to multiply this by 10 and that by 3 if I wanted to use those. Or I can multiply this by 2, all of them, and this by -5. That way you can choose to either eliminate the x's or the y's. It's your choice. Okay. This first equation, when you multiply everything by 2, becomes this. Your second equation becomes that. We add the 2 equations. The x's cancel each other out. So we got 56y equals -112. Divide by 56, and we get y equals -2. Now we substitute this -2 into the equation up here. No point in doing it with the decimals when we got this easier equation. So 50 times x plus 3 times -2 equals 14. Distribute that. Take this -6 over to the other side. We get 50x equals 20. Divide both sides by 50, and we get 2/5 or 4/10. There would be your point. This time we've got fractions. First thing we're going to want to do is clear the fractions, or the denominators of each fraction. So I'm going to multiply all 3 of these terms by 3. And down here, I'm going to multiply all 3 of these terms by 2. Excuse me. Now, I don't have an opposite pair, so I'm going to multiply this second equation by -1. I could have multiplied the top one instead. But when I do that, here's my top equation. Here's my modified second equation. I've got an opposite pair right here. And ironically, I also have an opposite pair right here. Well, these 2 give me 0, those 2 give me 0, so this entire left side gives me 0. But over here on the right, I get -3. Well, that's an untruth. So what this is saying, it is inconsistent, meaning there is no shared point, okay? And that also there is no solution, which gives us parallel lines which don't share any points. So if you get an answer that looks like this, then that's going to be parallel lines, no solution, inconsistent. Okay, here's another example. We look at this one. Okay, equation 1 and 2. We got this and this. They're in the correct sequence. So next thing we do is I multiplied equation 1 by -2. So I took -2 times x, -2 times -3y, and -2 times -9. I now have an opposite pair right here. Well, I've also got one over here, but that won't always happen. It's just on these problems that they're trying to show you inconsistent equations, okay? So this one is inconsistent. You get an untruth. There is no solution, and they are parallel lines. Okay, this problem, equation 1 and 2. We just brought down equation 1. Equation 2, we multiplied everything by -3. That gave us an opposite pair here and an opposite pair here. And as it turns out, these two values are opposites also, so we get 0 equals 0. Okay, when you get a truth, it could be 5 equals 5, 8 equals 8, okay? But when you get 0 equals 0, then basically what you're saying then is it's the same lines. It's identical lines, infinitely many solutions, okay? Here's another example. This time, we've got to distribute that 3 and this 6 before we do anything. Here it's distributed. And here we've put it in standard form. AX plus BY equals C. Okay, this one, the second one, we distributed and we put it in standard form. In order to get an opposite pair, we're going to multiply the top equation by -6, so these y's will cancel. Okay, so we get -18x plus -6y equals 42. The second equation remains the same. We add the equations. This negative and positive 6y cancel, leaving us -22x equals 44. With that, we get the solution x equals -2. Now we've got to go find out what y is. So we take this -2 and I would put it into one of these two simplified equations. But that's up to you. Okay, what they did here was they went back to the original 3 times -2 minus 1, which is negative. Oh, they did not go back to this. They just substituted it in here. 3 times -2 plus y equals 7. So they did go ahead and use it here. Simplifying this, we get -6. We take it over to the other side. So we get y equals -1. So we've got x is -2, y is -1. And what that is a pair of lines that crisscross somewhere in the universe at the point -2, 1. Another one by addition. I want an opposite pair, so I'm going to multiply this by 3. There's my resulting equations. I add them and the -3's are going to cancel. Divide, and you get x equals -4. You take that -4 and you put it into either one of the equations. They chose to use the bottom one. So 5 times -4 minus y equals -26. multiply that out, take it to the other side. So we're going to add 20 to both sides. And then if negative y equal -6, then positive y equals +6. So our answer then is the point -4, -4, 6. This is actually the same problem we worked earlier. I've got it in there duplicated for some reason, I'm not sure. So I'll just run through it. And so is this. Okay, the substitution method. We've been doing the elimination or addition method up to this point. Now we're going to do the substitution method. When you do a substitution, what you've got to do is you've got to get one of the two equations with a single variable isolated. In this case, they're going to take the 5x over to the other side, divide both sides by a negative, and they're going to isolate the y. So this becomes y equals, this becomes the substitution value that you put in the other equation. Okay, this y business right here came from the second equation. So now we're going to substitute this into the first equation. So there it is. We simplify it, divide, and we get x equals -4. Now, after you got the first variable, it's just like what we did on the elimination method. We substitute the -4 into one of these two equations. So they chose to use the second equation, and they're actually using this format right over here. So 5 times the -4 plus 26, y equals 6. That means that these two lines will intersect at the point -4, 1, 2, 3, 4, and up 6. Now that I've gone over one problem, let's go through the actual steps. What I've done is I've imported some materials from another algebra program and a college algebra program, and also some problems from 012 as part of that supplement part of the 013 part of this class. And I've done this every chapter. Okay, here are the rules for substitution. Isolate one variable in one equation, substitute into the other equation, and solve for the first variable. Okay, then we sub back to get the second variable. So here, let's go through this. We're going to pick one of these to isolate a variable. Well, the easiest individual variable to isolate is going to be this one because it's already positive 1y. So we'll take this 6x on the other side, and we get y equals -6x plus 6. Now, this becomes the substitution value that we've got to put into the other equation. So 3x minus 2 times the substitution equals -7. Here it is carried forward. First thing we're going to do is we're going to distribute that. Then we're going to combine like terms. Then we're going to move the 12 to the other side and divide both sides by 15 and simplify. So we get x equals 1/3. Now we have to go in with x equals 1/3 and find y. Well, the easiest way to use it is that isolation equation. So we replace this x with 1/3. -6 times 1/3 is -2, and add those. So the y value is 4. So that gives you the point 1/3, 4. That's the point of intersection of two lines. Here they're just checking their work to see if it's correct. Okay, here's another one. This time I've got a fraction in one of them. I've already got this isolated, so I'm going to leave well enough alone. I'm not going to clear the denominator. Now I'm going to take this -1/3 y plus 2, and I'm going to replace in the other equation right here this x. I'm going to distribute the -3. I'm going to simplify it. Take the 6 to the other side, divide, and I get y equals 3. That's my first answer. Now I'm going to take that 3 and I'm going to put it into the equation I isolated. Okay. So here's the substitution. Gives me -1 plus 2, gives me a value of 1. So I've got the point 1, 3. And they checked it. Okay, in this case, I'm going to solve by the substitution method. Looks like I need to sequence some arrows on my sheet. Okay, here I'm going to isolate this y right here. That's the easiest variable to isolate. What did we do? We took the 5x to the other side and changed every sign to get rid of that negative. Okay, now we're going to take this 5x plus 26 and replace it in the first equation. Distribute, simplify, divide, and we get x equals -4. Now let's find the other values. So we're going to go to this equation and we're going to put -4 in here. So y equals 6. That gives us the point -4, 6. Now, in this set of problems, you've already got an isolation here. We substitute this isolation for that y. We simplify it, and ultimately we get 30 equals 30. What did we say in addition when we got a truth? Well, that means that they are dependent lines, that they are the same identical lines, okay? And that there are infinite many answers. So you can write your answer as the set of x and 2x minus 6 values where x is any real number will work, okay, is your answer in set notation. But on this problem, I would expect you to tell me they are the same lines as well as being dependent. Okay, what about these two? I've already got an isolation, so I'm going to substitute it, simplify it, and I get x equals 1/2. I substitute in the 1/2 into this equation. So I get 5/2 minus 7/4 I've got to do the common denominator game, make this 10/4. Okay, make that 10/4. Minus 7/4 is 3/4. So in this case, these are intersecting lines that intersect at the point 1/2, 3/4. Okay, we've got x equals 5 minus 3x, 2x plus 6y equals 10. We've already got an isolation up here. Okay. Now, in this case, we worked this problem the hard way. We didn't work it by substitution. Okay. But we did this. We put these in the same order. When we did that, we noticed that all of these are twice the first one. Well, what's that going to happen? If we try to get an opposite pair, multiply this by -2, so the 6y and -6y would cancel, we would end up with this, and we end up with both opposite pairs. These two kill each other off, so we get a truth. So once again, they are the same lines. They are consistent because they do have intersections, but they are dependent because they are the same line. Okay, a few more problems. In this case, solve by the addition method. Let's clear the fractions. Okay, so I take 10 times this and 10 times that. Why did I choose 10? Because my common denominator is 10. So I took 10 times here and I took 10 times the 1, which resulted in this equation. Okay, now I've got to get an opposite pair with the second equation. I'm close. I've got a -5y and a positive 10y. So I can multiply both. I can multiply this equation up here by 2, or I can multiply by 10. Here we go. I've got this. I'm going to multiply by 2. I told you we multiplied by 10 to get rid of the fractions. We multiply by 2 to get a opposite pair. Well, it gave us 2 opposite pairs, 3 opposite pairs. So we're going to end up with 0 equals 0 again. Well, what is it anytime we get a truth? It's dependent lines, same lines, identical lines. Okay, how would you write up the solution for these identical lines? Any set of x and y values such that this is true or that is true. Now we're going to start in applications. We're only going to do one problem this morning, and then systems of equations. We're going to be dealing with some word problems. Then we're going to be going, if we get that far, into 3 unknowns and 3 variables, and then possibly some inequalities, but I don't think we'll get that far today. So with that, let's go to okay, now this is where we left off on Thursday. We did the problem of the school play. Okay, $9 tickets, $5 tickets, 400 tickets. Now, the cost for 400 tickets was $2,600. So in this case, we've got A for the adult tickets, C for the child tickets, A plus C equals 400 seats. $9 a piece for adults, $5 a piece for kids. At 400 seats, that's $2,600. To get an opposite pair, I'm multiplying this equation by -5, which gives me these two equations. I add the two equations and I get, as you see, first 4A equals 600, divide both sides by 4. The number of adult tickets is 150. Then we substituted in that 150 into my first equation and got 250 children's seats. Now, I'm reviewing that because I want you to notice how these equations were set up. We have adult seats plus child seats equals 400 seats. Then we have dollars times adults plus dollars times children equals the 400 seats times however much the mixture of dollars is to be $2,600. There's our two equations. This is a pattern that we will use in other problems. Now, the last thing we did Thursday is I put on this problem and I asked you to try to solve it before you came to class today. So we'll go over that problem now. Okay, here's the work in total. It's very similar to the last problem. In other words, we set up X equals the number of 2-point shots, Y equals the number of 3-point shots, X plus Y equals 34 total shots. Number of 2-pointers plus number of 3-pointers was 34 shots. Then we evaluate. We take $2 times, or 2 times the 2-point shots, 3 times the 3-point shots, 91 total points. Again, points, points, points. We find a opposite pair by multiplying the top equation by -3. We add the equations, -x equals -11, so positive x equals positive 11. So there are 11 2-point shots. Then we figure out the number of 3-point shots. We substitute the 11 into my first equation, and we get y equals 23 3-point shots. I created another variation. I mean, it's really weird to have more 3-point shots than 2-point shots. That's not very likely. So I redid this problem. I said the Shockers scored 66 of their points on a combination of 29 2s and 3s. So let's work this and see what we got. Once again, X is the number of 2-point shots, Y is the number of 3-point shots. The number of 2-point shots plus the number of 3-point shots equals 29 total shots. 2 points each times the number, 3 points each times the number, came up with 66 total points. A little lower score this time. To get an opposite pair, we multiply the top equation by -3. And then we add the equations, giving us an answer of 21 2-point shots. Now we're going to take that 21 and we're going to substitute it into my first equation. You see, we've got the same pattern for all 3 of these problems so far. Well, we subtract 21 on both sides and we get y equals 8 3-point shots. A little bit different problem this time. This time we're using with the I equal PRT problem, or A equals I plus I PRT. And in this case, David borrowed $10,000 to pay for his year of graduate school. He borrowed part of the money with a Perkins loan through the school that was 5%, simple interest. Remember, that's just I equal PRT. And the remainder of the money from his aunt at 1.4, again, simple interest. At the end of the year, he paid a total of $428 in interest. In other words, the interest on this $10,000 for the 5% money plus the interest on the $10,000 of the 1.4% money added up to $428. Now, how much did he borrow from each source? Well, let X equal the amount of the Perkins loan. I would have used a capital P. Y equals the amount of the aunt. I would have used an A. I like to make my variables somewhat stand for what we're talking about. It seems to make the problem make more sense to me. That's just a little problem-solving technique. Okay, here's your basic formula. Interest equals principal, the 10,000, times rate times time. Our year is going to be 1, so it's really a non-factor in this problem. The interest, okay, the amount he borrowed at the 5% plus the amount he borrowed at the 10%, at the 1.4%, was $10,000 he borrowed. Okay, there's our first equation. Doesn't this look like the previous 3 problems? Okay, now we're going to take the specifics. 5% times the amount of Perkins, 0.14% times the amount of aunt equals 428 total interest. Okay, because they tell you that. In other words, this is the I for both of these added together. So we're going to bring those 2 formulas over to the next page. Okay, this is the rate times the principal of the Perkins, rate times the principal of the aunt, and that equals the interest, because 1 is in each of these. Now, if it were for 2 years, then we would also have to have a times 2 on each of these. To get a, we're going to do this one by the substitution method. So we're going to isolate this X, take the Y on the other side. Now, this is going to be our substitution value that we're going to put where this X is. So this equation now becomes 0.05 times my substitution value plus 0.014 times Y equals the 428. We could have also done this one by the addition elimination method, which might or might not have been easier. Okay, so what we did next, although it doesn't forewarn you, is I took 0.05 times 10,000, which gave me 500, and 0.05 times negative Y here, and 0.014 times Y, that didn't change, and the 428 didn't change. Now I need to take this 500 to the other side, combine these 2 Y's. So this plus this equals negative 0.036, because remember, there is another hidden 0 behind this 5. This is 0.050, a negative 0.050, and this is a positive 0.014. So those give you a negative 0.036 Y. Okay, the 428 minus the 500 gives me negative 72. Divide both sides by negative 0.036, and it goes 2,000 times exactly. So he borrowed $2,000 from his auntie. Now we're going to take this 2,000 and sub it into probably this form of the equation, since we've already got x isolated. Okay, so basically we take 10,000 minus 2,000 equals 8,000. So that's how much he borrowed on the Perkins loan. So we have 2,000 from the aunt and 8,000 from Perkins. So that's our final solution. And technically we should go back and put it into our initial statements. Now, if you don't put it back into that initial statement, then you need to do this. Now, there's something in this that would lose you a point. Because this is money, you need a dollar sign in front of that 2,000 and the 8,000. And you also need the aunt and Perkins. Okay, what about this one? This one's an acid solution. Now, we've worked problems similar to this before, only we did it as a single variable. Now we're dealing with it as two variables. We got some 20% solution, and we got some 35% solution, and we want to end up with a 30% solution, which is between these two, and 15 ounces of it. So we're going to let X be the 20%, Y be the 35. Looks kind of like what we've been doing before, doesn't it? The ounces of 20 plus the ounces of 30 equals ounces of 15. That's our first equation. Again, it's very similar to what we wrote as our first equation in our other problems. In this case, then, the second equation, we evaluate the ounces of 20 and the ounces of 30. And here, we've got to have our 30% solution times the 15 ounces. Back on the previous problem, they told it was 428, and that was already the portion amount. But since they haven't given you that, then you have to multiply this. So we add the two equations. Well, first, we find an opposite pair. So we multiply everything in the first equation by negative 20. So we get this, the 15 times 20 here, 15 times the negative 20, we're multiplying everything, is negative 300. Okay, so here we get our second equation, and 15 times 30 is 450. So I'm just simplifying these two numbers over here instead of bringing it on a separate line. Now, I've got an opposite pair there, and I don't here. So I end up with 15y equals 150, y equals 10 ounces. So that means we've got 10 ounces of this 35% solution. By the way, if you worked this, I'd want you to box that answer. Over here, we take the first equation, we substitute in the 10, and we get 5 ounces for the 20% solution. So what that means then is if we mix 5 ounces of this 20 and 10 ounces of the 35, we'll end up with 15 ounces of 30% solution mixture. Okay, now we've got a little, excuse me, a little bit different problem. We're going to be using the D equals RT formula, distance equals rate times time formula. Plane flies from Atlanta to Los Angeles against the wind in 5 hours. That wind is going to slow down the airspeed of the plane. On the way back, with the wind, in other words, the wind is pushing the plane on the way back, it only takes 4 hours. So in other words, with this 5 hours, the plane got slowed down a little bit. With the 4 hours, the plane got sped up a little bit. Now, what we're going to want to do is find out what's the speed of the plane in still air. And by the way, the distance is 3,200 kilometers, which is about 190, but close to 200 miles. Okay, now, or not 200, 2,000 miles. Okay, here we go. We'll let x equal the speed of the plane, y equals speed of the wind. Remember, ultimately, we want to find the speed of the plane in still air. So let's just display our information. The distance, rate, and time are the factors of this formula, of this problem. With the wind, it's 3,200 kilometers. Against the wind, still 3,200 kilometers. Now, with the wind pushing you, you got the ambient plane speed plus the wind speed. Against the wind, you got the ambient plane speed minus the wind speed. Okay, when you're doing the round trip, if he giveth, he got to taketh away. Now, the time with the wind, 4 hours faster because you're adding the speed of the wind. On the way back, longer because you're taking away the speed of the wind. So now, given this information, we got the D equals RT problems, okay? But the distance is the same for both of these. So RT of these two is going to be equal to RT of those two. So here we go. They're going to take the time times the speed equals the distance. Time times the speed equals the distance. These simplify when you distribute to these two values. I don't have an opposite pair, so I've either got to do that or I've got to do it by substitution. In this case, I'm going to divide, since 4 goes into everything here, I'm going to divide everything by 4. And since 5 goes into everything here, I'm going to divide everything by 5. Those are just coincidental. It won't always happen that way. That simplifies the first equation to x plus y equals 800. The second equation, x minus y equals 640. We now have an opposite pair. So I add those two equations, 2x, the y's cancel, and I get 1440. Divide both sides by 2, and I get the speed in ambient wind is 720. Okay. Now, I'm going to go back. It does ask you to find the speed of the wind. So you have to find both the x value and the y value. If it only asks you to find the plane speed before, then you'd be done. So anyway, we're going to take this 720, and I'm going to use the simplest possible equation to put it into, which is this one. So I put in the 720 for x, subtract both sides, and I get y equals 80. So there's an 80-mile-an-hour wind. That's a pretty powerful wind, but remember, they're probably flying at 30,000 feet, and they're up in the, I can't think of the name of that wind cycle that dips down through the US. So here is our final answer with labels. Again, you got a label. Plane equals 720 kilometers per hour. Now, if this were miles per hour, you just use mph. And the wind speed is 80. Okay. Now, what's the key on these distance, rate, time, where you've got against the wind and with the wind? What he giveth on one, on the speed, he taketh away on the other, on the speed. Now, we're not going to actually do this problem, but it's almost identical to the airplane problem, okay? You got a 48-mile-an-hour trip, and that's a round trip, okay? Now, it talks about upstream, it gives you a time, and it talks about downstream. Basically, you've got to set it up with both give and take. Now, we're going to start on 3 equations and 3 unknowns. Up to this point, we've had 2 equations and 2 unknowns, and we had 2 methods of doing it. We had the addition method, or elimination method, it can be called, and we had the substitution method. Now, when there are 3 equations and 3 unknowns, you almost have to use the elimination method. So let's look at what we're talking about with 3 equations and 3 unknowns. When you have 3 variables, then those 3 variables create a point. Okay. I'm going to stop the share just a moment. When you have 3 points, we'll call them the tips of my fingertips, that creates a flat surface that they can rest against. That's why they use 3 legs on a photographer's tripod. That's why a 3-legged stool doesn't rock, but a 4-legged stool might, because the 4-legged stool might settle on three legs. Now, with that, anytime you create a plane like this, a flat surface, okay, this happens to be some internet, and that happens to be that problem that I worked out on the I'm not sure which one this one is. Oh, this was my second Wichita problem. But you got a flat surface. Now, planes can intersect at right angles. When that's the case, they intersect in a whole line that goes up and down. Okay? They can intersect like this, creating a line this way. Or they can cross through each other. Planes can be parallel and never intersect. Okay? Or you can have 3 planes that will intersect. Now I'm going to go back to my sharing, and we'll try to illustrate these possibilities. Now, I've got one sheet of paper leaning up this way. I've got this one vertical right here going that way. And then I've got one that's laying flat. And in this case, all 3 of these planes only intersect in one unique point. Okay? Now, to use our words from before, this is continuous because they share a common point. Here's another possibility that I alluded to a moment ago. I've got a sheet of paper this way. I've got one this way, or maybe cardboard, whatever, so it'd be stiffer, and another one this way. Now, if you look at these, although this plane number 1 and plane number 2 intersect in a line right here, plane number 1 and plane number 3 intersect in a line right there, and plane number 3 and number 2 intersect in a line there. there is nowhere that all three of these intersect at the same time. So in that case, there's no solution. Here is another case of no solution. So there are two possibilities of no solution here. Now, in this case, these three planes are just perfectly parallel, so they never intersect. So there's two different ways they can never intersect. Here, you get one intersection. Now, I tried to illustrate this where the planes were passing through each other. I used to have some plexiglass model that I cut slots in so I could show this a little easier, but they've gotten lost after I retired from public school. But in this case, it's infinitely many solutions because they all intersect in one line, and it's infinitely many pairs of points in that line. And then final possibility, the fifth possibility, is that it is all three planes are exactly the same plane, just like we had lines that were the same line before, where one line was just basically a multiple of the equation of the other line. So those are our possibilities. Now, you have this handout in your packet. I'd like you to get it out. I think it'll be real useful to you when you're working the problems on ALEKS. Now, there's a difference in this and the way that ALEKS is going to show it. In these, I number my equations 1, 2, 3. They number theirs A, B, C. And then we create equation 4 and equation 5, which for them would be equations D and E. And so they do just a little bit different labeling than I had when I made up this sheet several years ago. But if you've got it, it'll still work the same way. Okay, here we have three equations. Okay, I would call this equation 1, equation 2, equation 3. Notice they are all in the same format. X, Y, Z number, X, Y, Z number, X, Y, Z number. If they aren't in the same format when you get the problem, the first thing you do is put them in the same format. Now, pick any two of these. Okay, here's where they called them ABC. I called them 1, 2, 3. They say that they want to eliminate the variable V, or Z, excuse me. Okay, we've got some possibilities because we have some opposite signs in here pretty easily, although we also have them right here with the Y's. We could do that as well. You can choose any first letter to eliminate. They chose Z. Okay, in this case, they're going to take equation A or equation 1. They just wrote it down. Then they're going to take equation 2. They chose B here. And they've just written it down. Now, what they did was they multiplied everything by -1 before they wrote it down. I would do that as a separate step, but if you want to do it this way, you know, that's just fine. So in this case, we multiplied equation 2 by -1, giving us -2x plus y plus z equals +7. Now our z's cancel. So we've eliminated z, leaving us -1x plus 2y equal 3. I would call this equation 4. They're going to call it equation D. Actually, they're probably not going to call it. Now, the next thing they do is they pick two different equations out of these three. We chose A and B before, so this time we've got to use C with either one of these. Now, I would use C with this one because you've already got an opposite signs on. Well, actually, you do that one too. So it doesn't really matter. So they chose to use equation A, and they chose to use equation C, and they're going to multiply equation A by positive 2. 2x plus 2y minus 2z equals negative 8. So we've got an opposite pair of z's again because we're still trying to eliminate z's. Add these two equations together, they simplify to 3x plus 8y equals negative 9. Now, I hope I didn't, nope. Okay, now, I've got to put it in this form so I can make some notes on here. Okay, I call this equation D. And I call this equation E, or in my example, it would be equation 4 and equation 5. So at that point, let's go back to the slideshow. Later on, I'll come in and I'll sequence those so they'll show up right. Okay, here we go. So now I'm going to take equation 4 and equation 5, or in this case, equation D and equation E. And with those, I'm going to eliminate a second variable. Now, I only need two equations because I've got two variables. So I've got these two equations. I'm going to multiply the top one by 3 in order to get an opposite pair, which gives me 3x plus 6y, 3x plus 8y. This one is still D times 3. And this one is still E, which we're just bringing it down. Okay, and now our 3x's eliminate, gives us 14y. Those are opposites, that gives us 0. Divide both sides by 14, we get y equals 0. So now we've got our first answer. This is our first answer. Okay, so we're going to want to take this y, which is our first answer, because eventually we're going to have an ordered pair that's something for x. In this case, we'll have the y is 0, and then we'll have something for z. Now what we're going to do is we're going to start back substituting in, starting with these equations. We're going to take equation D. Okay, and we're going to substitute the y into this equation D that we made, or equation 4 according to my notes. Well, the 0 wipes out the 2, so negative x equals 3, x equals negative 3. So that becomes our second value. Okay, nothing like an iridescent pen. And we'll put that second value in here. Now, Questions? What?
Like, why y'all really arguing?
Did someone have a question? Hello? I can't see chat right now. But I heard one of you talking, I thought. Okay, we'll go on. All right, here, now we're going to take, at this point, we've got our X value and we got our Y value, -3 and 0. So now we're going to take these two values and we're going to put them into my first equation. This was the A equation. Okay. And we're going to substitute those. So we're going to substitute this -3 for the X. We're going to substitute the 0 for the Y, which just leaves us the -z minus 4. So we add 3 to both sides. We get -z equals -1, and z then equals +1, which is our third value. So here are our 3 values now, and there is our solution. Do any of you have questions about this? Now, let's go back and see how this fit with these steps that I showed you. First, we number or letter the equations. We decide what variable we want to start with. Okay. They chose equations A and B. They had to multiply B by -1 to get an opposite pair. So they added these two equations, eliminating the z in those two and giving us this one. Now they took two different equations. They chose A and C. You got to use C because you didn't use it the first time. Now, A or B, which one you use doesn't really matter. Use the one that the numbers are easiest. So we multiplied 2 times equation A, added them. We eliminated the z's and got equation E. Now we're going to take equation D and E. We've got to do a little bit of multiply by 3 so we get an opposite pair. And we combine those. Okay, so here we multiplied by 3. We got our opposite pair of 3's, and we got our first answer. So we've got to find equations D and E and add them to get our first answer, which also eliminates one variable. Okay, after you've done this, everything is a back substitution problem. So we take our first answer, the y's, we put it either into D or E, it does not matter which one, and you solve for X in this case. Okay, now we've got 2 values. So we're going to take this X and Y. We go back to either A, B, or C equation, and it doesn't matter which one, A, B, or C, whichever one's the easiest numbers, and put them in and solve for the third variable. So the number you eliminate first, the variable you eliminate first, will be the variable you solve for last. And then you get the 3 values and you put them in an ordered pair, a 3-dimensional ordered pair. Okay. Let's go through another one. This time we got fractions. 2 times 3 is 6. 6 is the common denominator. So they're multiplying this equation A by 6, giving us this. Equation B is okay, it doesn't have fractions. C doesn't have fractions. But what they did do on C, you notice here we go X, Y, Z number. X, Y, Z number. X, Z, Y. So we've got to take this Y over to the other side and put it in X, Y, Z number format. So we got the 6X, we take the 3Y over, we got the Z, and when we subtract this 3Y, it leaves 0. So here are our modified A, B, and C equations. We'll use them pretty much from here on out. Well, maybe. We'll see. I chose to use A and B first. I have to multiply B by 2 to get an opposite pair. Doing that, I'm going to eliminate Z again. Again, you can choose to eliminate any one of the variables first, except it might make a difference what you multiply one of these by. That gives us equation E, or D rather. Now, we take equations B and C. Again, the difference is we got to use C. We can use either one of the other two. We really didn't have to do anything on these to get the Z's to be an opposite pair and eliminate. So that gives us equation E. Now we're going to take equation D and E, and we're going to combine them. Well, we've got to modify them a little bit. We took this one times 2. We took this one times 5. So this is still D and E. This one is 2 times D. This one is 5 times E. That was a mess. I'll have to redo that later. And you get your first solution. Okay. Now, we write it down. This time we got X first instead of Y first because our opposite pair worked out to eliminate the Y's. So we put in the X in the value down here. Then we take that and substitute it into one of these two equations. So we chose the first equation. X is replaced by 1. Here you get negative 5y. You've subtracted 8 on both sides. And y equals 4. So here's your second value. Now we take those two values and we go back to either equation A, B, or C. This one happens to be equation A. And we substitute in the two values we've got, and we find our value of Z, which is 6. So then our ordered pair is the point 1, negative 4, 6. As you see, with the exceptions of labeling the A, B, C, D, E instead of equations 1, 2, 3, 4, 5, the method on my sheet is identical to what we're doing on these problems. Now, I'm going to give you a little bit of good news. Although there will be one problem like this on my chapter 5 test or exam 5, there will not be one of these on the final. You might ask why? Because they take too much time. One of these problems takes you at least 10 minutes. Okay, and you got 100, and you got what? From 1 o'clock to 2:50. Okay, so that's an hour and 50 minutes. You don't want to, or 110 minutes total. You don't want to use 9% of your total time on one problem when there's 32 problems. Okay, you're going to, on the final, you're going to need to do about a problem every 3 minutes. That's about what 3 to 3.5 is what you're authorized per problem. Now, some of them will be easy and you'll do them fast. Others will be harder, but there will not be one like these on the final. Well, that brings up this problem. We're not going to do it, but we will go to this one. Actually, we're going to stop right here because I don't have enough time to do this problem today. Not and finish by 12:20. So this is where we'll take up tomorrow. If you want to try it in advance, that's up to you. I'll be glad for you to do that. X plus y equal 19, 2x minus z equals 4, and x plus y plus z equals 29. Now, there is a hidden plus 0y in this one that you need to insert in there. Okay, that's a hint on this problem. There is a hidden 0y that you need to use. They've got it right here. They just did not show it. Okay, so in this case, plus 0y. Okay, now 0y plus y is y, 2x is 3x. Well, you've already got an opposite pair of z's. So they've chosen to eliminate z again. Oh, by the way, you've got a plus 0z in this one. That you need to watch out for. Okay. Well, if you want to try that one ahead, you can. Otherwise, we'll finish it up on tomorrow. So with that, I would say have a great afternoon. Good morning. It's time to begin. Today, we're going to finish up with 3 variables, 3 equations, which is a non-final topic, but it is on my test. And then we will go into inequalities, systems of equations with inequalities, graphing those. So we'll be doing that. And at this point, we will just finish up on these 2 topics. Tomorrow, we'll start on chapter 8, which is sequences, and finish up on the stuff on Friday. Then on Monday, we'll do an exam review, a little bit of final touch-up topics. And then on Tuesday, you will have your exam 5. And exam 5 will be online rather than in person. So that said, we'll go ahead and get started. Okay, this is where we left off yesterday. And so here you have 3 equations with 3 variables. Now in the past, we've had all 3 represented, all 3 variables represented. In this one, we have some missing variables. For example, here we have the z missing, here we have the y missing, and here they're all present. Now, what that does is that opens up some opportunities where you don't have to go through all of the steps that you had to on the previous three problems. Because it's missing, if I eliminate these two, I'm automatically down to two equations that I can deal with. Okay, so we'll go ahead and start on this. I chose equation B and equation C. Okay, I have an opposite pair for the z's. I combine those, I get 3x. I get 1y, the z's go away, I get 33. So I have two equations, two unknowns right here. Then I take equation A, which has the x and y with the z missing, and I combine it with this equation D we generated, which only has x and y. And we can work these two right now. What we ended up doing is, because of these missing values, we were able to skip doing an equation E. So now we're going to take these two, we're going to combine them. We did that here. I have to multiply by -1 to get an opposite pair. So that results in these two equations. I cancel out the y's, leaving -2x equals -14, x equals 7. Now, I can take that x equals 7, put it into equation y, and that gives me the value for y. So again, it saved me a little bit of trouble going backwards. I now have two variables solved, the 7 and the 12. Now I take those two variables and I substitute it in on the z equation. Okay, in this case, I chose equation B from the previous page, which has x's and z's in it. So I replace the 7 here, got 14, and z is equal to 10. So my solution, 7, 12, 10, the point. Now that kind of ends our discussion of three variables, and we're going to go on now to working with inequalities. I'll give you a moment to read this. Basically, the only difference is we're replacing an equal sign with a less than, greater than, less than or equal, greater than or equal. Now, your solution set, anytime you have an inequality, instead of having an answer, you have a solution set. Hopefully you remember that from before. So in this case, the solution set is the set of all ordered pairs that'll make it true. Well, duh. And then the graph represents the inequality. Here's our first example. Okay. Here we've got the equation y is greater than x minus 4. Now, since this is in y equals mx plus b format, notice if y is greater than whatever the equation is, that's going to indicate that areas above the graph of the related line are also included. In other words, anything up here, any point you picked out here would produce a true value for this equation. For example, if you pick the point -2, +4, substituted it in here, the +4 there, the -2 there, and you would see that you would get the correct answer. Now, so let's go ahead and work this problem. We use a dashed line because it's a greater than symbol or less than symbol. We use a solid line if there's an or equal on it. Now, once again, first you just graph the line normally. changing that to an equal sign and solving the equation. Now, to do this, if that were an equal, okay, our y-intercept is -4 down here. Our slope is 1/1. So here we would go up 1/1, up 1/1, up 1/1, up 1/1. So there's our line. We use dashed because it's not an or equal. Because this is greater, this means, although it will not include the line, any xy value that's up here that's greater than the ones on the line or higher than the ones on the line will also be true and produce a truth. Okay, here's the steps of how to graph it. Well, I've kind of told you those. Replace the inequality with an equal sign, graph the equation. If it's a less than or greater than, draw it dashed. If it's an or equal, draw it solid. So the first thing you do is you graph the line. Then they call this a half plane because it actually extends forever. It's not limited to the size of our graph that we physically show. Now they're saying test a point and see if it's inequality, but I'm telling you that it will give you the correct thing. Now, in this case, they're using the test method. I would not use that method. What I would do first is I would change this equation into first 2y is less than or equal to -4x plus 8. In other words, I took the 4x over to the other side. Then I would divide everything by 2, less than or equal to -2x plus 4. Then I would use this to graph the line. So my y-intercept is +4 up here. And then I'm going to go down 2/1, down 2/1, down 2/1, down 2/1, down 2/1. Okay, negative slope, downward left to right. Because this is an or equal, I draw a solid line. Now then, after I've done that, after I've drawn my solid line, I look at this symbol when it's in y-intercept form, okay? It's everything smaller than or equal. All y values that are smaller than the ones on the line. So in other words, for this point right here, all of these are smaller than that 0.4 for y value. Right here, we've got a y value of 1. Everything that's smaller or less than 1 is a y value that it can be. Same way here, we've got a -1 for the y value. All y values below -1, and so on and so on and so on. Now you say, well, what about this stuff? Remember, this line keeps going forever out to the left, so that's why all of this is included also. Now, this is the test method right here, okay? They chose the point 0, 0 to test. X is 0, y is 0. They used the original equation. 4 times 0 is 0, 2 times 0 is 0. Is 0 less than or equal to 8? Well, yes, it is. So that means this origin right here, Okay. This point at the origin is in the shaded area, so that's their way of checking to see if it's true. And I'm going to get rid of that because I don't want it there. Okay, let's go on to the next one. Now, my note down here, in this case, after we put it in y-intercept form, again, we have a less than, but we have a less or equal. The or equal dictates a solid line. The less than part of this indicates that we will have areas below those that are on the line, or in this case, to the left and down. What if you've got a vertical line? The slope is undefined, and the equations are all in the form of x equals something. Well, in this case, we've got a greater than. Well, if this were x equals 2, we would have a solid line. But because it's x is greater than 2, we have a dashed line. Now, what does this tell us? This tells us all x values that are bigger than 2 will work. So all of these x values up here, right here, is an x value of 4. Right there is an x value of 5, 6, 7. Right here is an x value of 1. No, 3, which is bigger than 2. Here's an x value of 4, bigger than 2. Okay. It is not included, so we can't include the 2. That's why we use the dashed line. Well, guess how a horizontal line is going to look? Well, not much different. In this case, a less than symbol. So here we've got all values below the horizontal line of this graph right here. And we use a solid line there. What if this were greater than or equal? Then we would have the shaded arrow or shaded area and the arrows going upwards instead of downwards. Now, when you do a problem, you can either shade the area or you can show the arrows like I've done here. On this one, what if they had had a less than symbol instead of a greater than symbol? Well, the arrows and the shading would have been going to the left then instead of to the right. What if you got 2 equations? Well, here's the first one. I changed it into y-intercept form, and now I graphed it. Because of the or equal, I'm going to use a solid line. My y-intercept is 3, and I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Solid line. Because this is greater, I have to use y values higher than the ones on the line. Now I go to the second equation. I'm going to graph it. Okay. -1 is my y-intercept. And I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. They chose fairly simple equations to demonstrate this with. Now, because this is a greater than symbol, not an or equal, I have to use a dashed line because I have a positive slope. I'm going left to right uphill. Now, because this is greater, then this graph by the factory is wrong. This thing's wrong. Because greater, it should be the area shaded up here. Okay. Huh. Never noticed that before. Okay. Well, interesting. Let's try doing. Nope, that won't do it. Well, I can't alter this one. I'm going to have to completely change this because this is greater than. It should have been up here, and there should have been a triangular area up here in this corner instead of that corner. Okay. Should have been this area up in this corner instead. And all of this brown should have been up here. So, interesting. I'm glad I caught that. Okay, now, this is a weird one. They're graphing three different linear equations. Now, this is not the same as what we were doing before. Okay, these are not planes. They are not X, Y, Z's. These are just X, Y's. So each one is a line, not a plane. So we don't use that three variable thing on this, but I did number these equations 1, 2, and 3, just so I could keep track of what I was doing. Well, what I do is you can graph each one of these individually, okay? Now, after you graph them, you can see physically where the vertexes intersect. Or you could do it mathematically. Here they chose equation 1 and equation 2, and they did simultaneous solution on it. They didn't show the steps, okay? And what they ended up doing is finding the point -4, 2 as the point of common intersection of those two. Then they did the same thing for 1 and 3. Then they did the same thing for 2 and 3. And they figured out these points right here. Now, just simply by graphing them, you would figure that out, okay? Because y plus 2 gives you y equals 2, and so on. Anyway, the point of all of this is the solution is the area contained inside all three. Why? Because this one, it said everything bigger than this horizontal line, y plus 2. Here, it said everything smaller than that line, or in other words, everything this way. And then the third one, it's everything this way. But the only area where they have a three-way overlap is right there. Let's see if I can demonstrate that any better for you. Okay, for this equation, everything here, whoops, I got to undo that. That's a greater than in the original problem. In the original problem, that one was greater, and then the next two are less. So in this problem, everything up here counts. Okay, in the second problem, Okay. This becomes y is less than or equal to, that's a positive y, x. Okay. There's that y equals x 45-degree line and everything below. Okay. Right here it is. Okay. And then this one is y equals negative x. Oh, wait, this one I left off the +2 on that one. So here, less than. So here are those three equations. In this case, here is the y equals negative x. And it says that it's everything less than. So that would be everything here, including the line. Okay, and then the final one okay, the final one is this is y equals x plus 2. So that moves up the y-intercept to 2 and over 1 up 1. And that would be everything. I got to use something besides blue because blue and green makes yellow. So let's try a different color on this one. Let's try purple and see what happens. In other words, everything down like this. Now, what part of it is contained in all three of them? Well, you can't really tell on this, but it's bounded by that bottom line right there. Okay, so that's why it's this area just here in the middle. All right. So with that, you know, we're talking about stuff below this line, and the only thing that fits into all three of those criteria is this area. Probably spent a little too much time on that problem. That ends our information that we've got in chapter 5. I would start studying that, working on it, reviewing on it. Tomorrow we will start on sequences and series. I don't want to start on those today. So today we're going to finish up a little bit early. Okay. So what I would do if I were you is I would try to get all of the chapter 5 material in ALEKS finished now. Use this other 20 minutes or so to work on that. And then you can continue to be ready to go on tomorrow for our sequences in chapter 8. And we'll spend about 2 days in sequences. Then you'll have your test review and test over 5. And then after we do 5 on Tuesday, Wednesday, we'll go over 5 and then start reviewing for the final, which will be over the weekend after that. So not this weekend. Well, Actually, it is this weekend, I guess. So the announcement will come out from the math department in terms of the time frames. The final will be on ALEKS this semester. Now, on both of these tests, I get to wait. Zoom thinks I'm playing music. Okay, both on the chapter 5 and the chapter and the final. At least on chapter 5, I'm going to give you an option. The option that you will have in chapter 5 is you'll see your test score immediately. Now, on chapter 5 test, you will have two chances to take it. You can take it the first time. If you don't like your score, you can redo the test. Now, the retest starts from the beginning. You start totally all over. You have a specified amount of time that you can do it in. Then ALEKS will choose the highest of your two scores. If you wish, and this is optional, if you wish, you can send me your work, just like the remote students have done in the past, just like you guys, well, the 4 of you who attend class haven't been doing that, but you can put it into a PDF and email it to me, just like we've been doing in the past. I'll send out instructions for that. And then I will grade partial credit on. Now, because there are 5 different variations of Unit 5 test, you're going to have to write the exact original problem down on your work for me to be able to evaluate. And I'm going to have to grade each test uniquely because there's not going to be one common answer key for all of the students in the class. Again, sending the work to me is optional. I will give you a deadline that it has to be to me by if you want the partial credit opportunity. Now, I hope to be able to do the same thing on the final. It's not determined by the university whether you have to submit your work. And if you don't show your work, you don't get credit, even if ALEKS counted it right. Or if the showing your work is just a possibility for a higher grade like it is on my Unit 5. On Unit 5, when you send it to me for partial credit, as long as you show your work, you will not have any lower of a grade. Okay, so if there are any questions, save them for me tomorrow and either text them to me or email me. And as soon as I know more about the final, I'll get that out. Sometime over the weekend, I will get the information out over your over your chapter 5 test. With that, have a good day.